Hello everybody, welcome to the part 2 of geometric mean and arithmetic mean. In the previous video, we have shown that if given some x1 to xn, if the product of x1 to xn equal to 1, then we have the sum of xi to x1 to xn is greater or equal to n. Now, in this video, we continue with proving the theorem. So theorem 2, we have shown that if geometric mean of positive number is less or equal than the arithmetical mean. So let's begin. Proof. We let x1 to xn be some positive number and define that a is equal to x1 to xn divided by n, and that is our arithmetical mean. That is our arithmetic mean. And g be x1 to xn and taking the m root, and that is our geometric mean. And since x1 over g dot x2 over g all the way to xn over g is equal to g power of n to x1 all the way to xn, and remember g is the m root of x1 to xn, so this is equal to 1, which is satisfy the condition of what we have in theorem 1, so we can just use theorem 1. Therefore, we get that x1 plus g to all the way to plus xn to g is greater or equal than m by theorem 1 we showing in the previous video. So we do a little bit rearrange of algebra. We got and finally we have that x1 all the way to xn over m is greater than or equal than g, and that is our arithmetical mean. Next, I'm going to show you a corollary of using the geometric mean and arithmetical mean, but before we need some definition. So definition, the number C alpha is equal to A1 alpha plus all the way to AN alpha, so that should be AN alpha divided by AN in power of 1 over alpha is termed the mean power of number A1 to AN of order alpha. And then next corollary is that, so for example, why in that C1 is equal to A1 plus AN over N, and that is our arithmetical mean, and C minus 1 is equal to A1 to minus 1 to n to minus 1 over n. Minus 1, and that is equal to n over 1 over a1 plus all the way to 1 over a n, and that is our harmonic mean. Harmonic mean. Okay, now we can go straight to the corollary. For corollary, we can think about corollary as some immediate result of the theorem we proved before. So, if a1 to an are positive number, and alpha is less than 0, less than beta, then we have G is less than equal than C beta and greater than equal than C alpha, and C alpha and C beta is what we defined above. So let's see why this is true. Proof. From theorem 2 above, we know that we have that a1 power of alpha to all the way an power of alpha square root of m is less than equal than a1 alpha plus an alpha, and that just geometrical mean is less than arithmetical mean. Now multiply both sides by power of 1 over alpha. Now we have two cases. One case is alpha greater than 0, the other case is alpha less than 0. So if alpha is less than 0, then G is equal to a1 alpha to an alpha m power of 1 over alpha. If alpha is less than 0, we times 1 power of alpha, we flip the order of inequality, that we have that a1 alpha plus all the way to an alpha over n 1 power of alpha, that is equal to our C alpha if alpha is less than 0, and if alpha is greater than 0, we have that a1 alpha to all the way to an alpha power of n is less than a1 alpha plus all the way to an alpha over n power of 1 over alpha. That is our C alpha, and that is our G. And since alpha is greater than 0, we keep the inequality, so we have what we want. And that's all I got for today. If you guys want to see more inequality or more interesting mathematics, please stay up for the next video. Thank you and have a great day.